a number of different goals and deliverables associated with it. And what I'm going to be talking about today, the climate change sensitivity part, is just one of many. So we also did a number of climate data downscaling attempts and have that data available. I give the URL up there if anybody's interested in checking out for more information here. We did a number of habitat and climate suitability models, some more sophisticated species population modeling, and of course the climate sensitivity database, which I'll be referring to in a minute here. And then Julia, right after my talk, is going to be presenting some of the case studies that use that data and those tools and applied it in a management setting. So definitely stay tuned, because I think that is going to be very cool as well. So, okay, so throwing around a lot of terms, vulnerability. I am defining, or we are defining vulnerability as really the susceptibility to climate change. And when I say climate change, I mean the climatic variability, so interannual or decadal, whatever it is. So variability and those extremes. So the susceptibility to climate change and the being unable to cope with that change. So that's how I'm defining vulnerability, just so we're all on the same page with that. And generally, vulnerability is composed of three general components, right? So we've got sensitivity, and again, I'm defining sensitivity here as the inherent sensitivity of a species or a system. So whichever it is that you're looking at or trying to assess or quantify, that inherent sensitivity. The exposure, so the rate, magnitude, and character of climate change, and then the ability to cope, or the adaptive capacity. And so these terms, I'm using these terms all surrounding natural systems, right? That's why we're in the room, I guess. But species and ecological systems. So I'm defining those terms around those concepts. So this is a screenshot of what we're referring to as the Climate Change Sensitivity Database. Now, again, the URL is up there. This is a publicly available online database that the partners, the collaborators of this larger vulnerability assessment decided we really needed a central clearinghouse for information about species and ecosystems and their inherent sensitivity to climate change. And we decided that this was one of the tools that would be best suited for getting some of that information out there to other managers. Okay, so these are key collaborators. University of Washington worked with Forest Service, Park Service, U.S. Fish and Wildlife Service, Washington Department, Fish and Wildlife, Oregon Department, Fish and Wildlife, Idaho Fish and Game, Nature Conservancy, Defenders of Wildlife, National Wildlife, so the list goes on, right? But we all decided that this would be a good idea. Then we had to come up with how to define or assess inherent sensitivity to climate change for species. Systems is kind of different, but I'm just focusing on species today. So we came up with a laundry list of factors and had to boil it down because we couldn't do them all. And we realized that there was some commonalities in the list that we came up with. So we condensed it down to these 9 factors. And you'll notice that, in particular, the last one, it maybe isn't so climate related. This is great because this is our wild card. You got to have a wild card when you're trying to define something as general as sensitivity. And so going through a series of workshops with our partners and experts of these species, we realized really quickly, the managers told us right away that you needed a category that you would be able to weight the other factors with. So for example, if a species has extremely low population number, maybe there's only 10 of them in existence, that is likely going to predispose that species to be more susceptible or more sensitive to climate change. So that's my other factors, my wild card. I like that one. So this is an example. This is the screenshot from whitebark pine, high elevation tree species that is particularly sensitive to climate change. And this is just to give you an idea of how we went about the process. So before we had experts rank those 9 factors, which are highlighted in that box there, we all went through, as a whole group, just like this room here, through an example species. I gotta warn you, it was a little painful the first few times we attempted this, because once you get a lot of experts in the room on a particular subject, they might have different opinions about how sensitive it might be to climate change. But we did that. And it was good because it not only gave them an opportunity to get clarification as to what we're trying to get at in answering questions associated with each of these 9 factors, but it also calibrated them. And that's an important piece because there are some inherent biases with expert judgment. And we wanted to try and counter that. And this process really helped us do that. So work through an example species, and then we would break up into groups, or some folks decided that they wanted to work independently, and then would assess the sensitivity of a particular species. And we asked them to rank on a scale from 1 to 7, 7 being highly sensitive, each of these factors and how they relate to climate change for a particular species. We didn't quite stop there, though. We asked them to also give us their confidence in each of those values. And so then that is the box on the far right. And that was really informative as well, for many reasons, which I'll get into here in a minute. But first, we wanted to see, we looked at about 200 species in the database. Right now, I think there are about 260 or 70 that are completed. We looked at about 200. And we grouped them together by taxonomic group, see if there are any patterns. And lo and behold, amphibians and reptiles, the box on the far right, was more sensitive relative to the other taxonomic groups. Probably not a big shocker for a lot of you, but it helped us have some confidence in the database that it was probably doing what we intended it to do. So the black heavy bar in the middle of the box is the median score for all the species within that taxonomic group. And then the whiskers are the range of sensitivity scores. Birds, interestingly, we had the most number of species in the birds taxonomic group, but it also had the smallest range of scores, which we thought was pretty interesting. But then we wanted to get into a little bit more detail. And so these are individual species scores for those 200 or so species, plotted with sensitivity scores on the bottom. So these are essentially the average of all those factors. And it goes from low to high, as you can see, and then confidence on the y-axis from low to high. And I think this is really interesting because you see birds are blue, mammals are, it's kind of a funny color on here, but orange, plants are green, and amphibians and reptiles are red. You can see those amphibians and reptiles falling out in that upper right quadrant. So what is driving some of those scores? What's causing or what's leading to those higher sensitivity scores? And we identified that the factor, sensitivity factor as we're calling them, sensitive habitats was most often identified as having those high scores for birds, mammals, and amphibians and reptiles. Now, each of those, there are a multitude of different sensitive habitats out there, and this is climatically sensitive habitats. And for birds, it was grasslands and balds. For mammals, it was alpine areas, and amphibians and reptiles, seasonal streams and the riparian areas associated with them. Different story with the plants. For plants, it was the ability to disperse, so both distance and whether there are barriers preventing that dispersal. couple caveats associated with this work, of course. Sensitivity is not vulnerability, so we are not indicating what species are more vulnerable to climate change. Sensitivity can also vary by life stage, so juvenile will have potentially different sensitivity values than an adult. And of course, geographically, there can be differences throughout its range. Further research can look at adding in those components to try and get at vulnerability. Oh, and if you're interested, I'm defending my PhD here in a couple weeks, and I attempted this with some tree species. So I invite you to come along September 26th over at Anderson Hall. But we did attempt some of that. So if anybody is interested, we have some metrics of vulnerability for some species. Nonetheless, sensitivity information can be particularly informative, I think, in a management setting. So for instance, species that have high sensitivity and that we have high confidence associated with those sensitivity scores, maybe those are good candidates for adaptation now. Maybe those are the ones that we try and devote more resources to identifying what strategies can help build resilience and resistance for those species. Now, the species that have lower sensitivity, but that we still have high confidence, maybe those are less of a priority. So in a real general sense, this information can help identify those different priority settings. And of course, the species that have low confidence are automatic data gaps. We need more information, and maybe that information exists in the scientific literature, and we just need to go identify it or get some interns or some grad students to do it and fill in some of those gaps because it's out there, we just need to populate it. So sensitivity can be informative to prioritizing management and ranking species and their different sensitivities to climate change. And we hope that it can be a resource